Hello, in this video I'll demonstrate how to analyze the Excel output of simple linear regression. First, let's see the data. A researcher was interested to develop a model to investigate if the numbers of hours using cell phone per day impact the numbers of hours of sleep per night. By collecting the data, as you can see here on the slide, and go into Excel and run the simple regression. Here is the output that we received after running the Excel simple regression tool. So the first step will be, first of all, to understand the coefficient of the model. We have two coefficients, the intercept coefficient and the numbers of hours using cell phone coefficient. Both coefficients help us to determine the least square line to represent the trend line of the data. Here is the scatter diagram of the data, and as you can see, we see a negative slope, a trend that is negative, which means that the numbers of hours using cell phone per day have a negative relationship to the numbers of hours of sleep per night. For any additional unit of using the cell phone per day, we are going to lose a certain portion of hours of sleep. So how do we build a model? We're looking at the coefficients, and our y hat, our estimated equation, our estimated dependent variable, will be equal to 10.954, subtracting 0.478 times our x variable. This equation gives us the relationship between our independent variable x to the dependent variable y. Our next step will be to analyze the rest of the output and focus on the ANOVA table. The ANOVA table will help us to do later on testing on the significance of this model. As a first step, let's understand the structure of the ANOVA table. The first column, degree of freedom, have 3 items. The degree of freedom for regression, represented by k, the numbers of independent variables. In our model, we have 1. The degree of freedom for residuals. In this model, it's represented by n minus k minus 1. In simple linear regression, it's end up to be n minus 2. And the last one, degree of freedom for total, which is represented by the total observation n subtracting 1. The next column, the SS column, represent the SS regression, using this formula here on the slide, the SSE formula, which is the SS residual number, and the SST, which is the SS total. The next column, the MS column, represented by the MS regression, which is the SSR over K, the MS for residuals, which is the MSC, equal to SSC over n minus k minus 1. And these two numbers will help us to calculate the statistic, our F statistic for the test. So the F statistic is calculated by the ratio of MSR over MSC. The next items that I would like to go over will be the R squared, the multiple R, and the standard error. Let's start with the R squared. The R squared is the coefficient of determination, and is basically showing us the portion of the total variation in the dependent variable that is explained by the variation in the independent variable. The larger the value, a stronger relationship we exhibit. So in this case, we have about 74.45% of the portion of the variation in the dependent variable that is explained by the variation in the independent variable. We can calculate R squared by taking and using ANOVA components, the SSR over the SST. The next step is to find the standard error of estimate. We label it as S epsilon, and it's measure how the data varies around the regression line, similar to a concept of standard deviation. The closest the data will be to the regression line, the standard error of estimate will be a small value. The further away, it will be a larger value. We usually compare this value to the average of y, and will determine if it's considered to be small enough if the S epsilon, the standard error of estimate, is less than y bar, the average of y. You can calculate the standard error of estimate by taking the MSE in the ANOVA table and square root. The next portion is the multiple R. This is basically the coefficient of correlation, lowercase letter r. And it's the square root of the r squared. Okay, so when you take the square root of 0.744, you will get a positive number. In order to understand what is the real sign for the coefficient of correlation, you need to look at the coefficient of the slope of the line. In our case, have a negative relationship. You can see the negative sign. So the coefficient of correlation in this example is negative 0.862 because we have a negative relationship between x and y. So this completes our Excel output analysis that you will need in our course. We will continue to work with this Excel output and we'll explore more items in our next course.